Hi friends, in this video we see 50 expected questions from electron devices and circuit subject. This may be expected in TRB and TNEB exams. The first question is, the recombination takes place when a crystal is formed, the electron falls into a hole, valence electron becomes conduction electron, none. So we know recombination takes place when electron falls into hole. So option A is the right answer. Right. The unit of mobility is meter square per volt per second, meter per second, joule per Kelvin. So it is meter square by volt second, direct question. Okay. The current flowing in a germanium based PN diode is 2 into 10 power minus 7 ampere. So I is equal to 2 into 10 power minus 7 ampere. When reverse bias is applied. So what is the current flowing in reverse bias? Reverse saturation current. So it is I0. The current flowing when 0.1 forward bias voltage is applied. So when VF is 0.1 volt, so what is forward current they are asking. So we know IF is equal to, what do you call, IF is equal to I0 e power 40 VF minus 1 for germanium diode. So I0 is 2 into 10 power minus 7 e power 40 into 0.1 minus 1, that will be giving 10.7 micro ampere. So the answer is 10.7 micro ampere. Next question is, a silicon diode has a bulk resistance of 2 kilo ohm. So RB is 2 kilo ohm. Forward current IF is equal to 1 milliampere. Right? It is a silicon diode. So diode is silicon diode. What is the value of forward voltage? For silicon diode, forward voltage is VF is equal to 0.6 IF into RB. 0.6 plus 2K is 2 into 10 power 3. IF is R is 2 into 10 power 3. IF is 1 into 10 power minus 3. So it is 2.6 volt. Is there anything? Yes. Here option D is the right answer. Next one, find the current through the given circuit. Simple, very simple. So I apply KVL. So minus 5 plus here current, that is assume I into 430. This is diode, we don't know, so we have to put 0.7, right? The voltage drop is 0.7, so this indicates I is equal to 5 minus 0.7 divided by 430, that is nothing but 4.3 divided by 430, right? So 4.3 divided by 430, 4.3 into, so it is 10 power minus 2, which is nothing but 10 milliampere, right? So answer is option B, 10 milliampere, right? Okay, next one, LED emit light when its electron and hole recombine, or light falls on it, or LED gets heated, none. So when it will emit light when electrons and holes recombine, right? So option A is the right answer. The dielectric, to detect light intensity, dash is used. To detect light intensity, we have to use photodiode. So option A is the right. In a CB configuration, emitter current is CB configuration. Emitter current is IE 3 milliampere. Collector current is 1.5 milliampere. Right? What they ask? Base current. So in CB configuration, base current is nothing but IB is equal to IC by IE. Right? Common base. So IC is 1.5 milliampere, I is 3 milliampere, so it is 0.5 milliampere. Next one, determine IC and IB for the transistor shown in figure. So from this we understand it is common emitter transistor. Fine. So the transistor is common emitter transistor. Here what they have given, IE is 10 milliampere, alpha is 0.987. So what happens? So from this what they are asking? They are asking IC and IB. So we know alpha is equal to IC by IE. Fine. So alpha is equal to IC by IE. So it indicates, this implies, so it is common base, not common emitter. Please understand, it is common base transistor. So alpha is nothing but, because they have given alpha value, so 0.987 is equal to IC by IE 10 milliampere. This gives IC is equal to 9.87 milliampere. We know IE is equal to IC plus IB. IC is 9.87, IE is 10. This indicates IB is equal to 0.13 milliampere. So we got the answer. Right. Next one, if beta is equal to 100, what is the value of alpha? We know the relationship between alpha and beta is alpha is equal to beta by beta plus 1. It is 100 by 101. Right? Okay. Next problem. So beta is 200, IB is 125 milliampere, find IE. So beta is given, so it is common emitter. Right? Okay. So what we have to do? We have to find IE. So IE is nothing but IC plus IB. Beta is given by, beta is IC by IB. Right? So IB they are given, beta they are given. From this we can find IC. So IC is equal to beta into IB. If you find IC, it will be beta 200, 125 milliampere. So it will give 25 milliampere. So IC is 25 milliampere, IB is 125. Right, this is 25 milliampere, IB is 125 milliampere. So IE is nothing but, right, 125 milliampere. So it is 125 milliampere. This is 25 milliampere. Right. So the answer is 150 milliampere. Right. Okay. So the next question is, which of the following configuration is much less temperature dependent? So as per that CE, CB or CC, it is CB is less temperature dependent. So option A is the right answer. Direct question. Emitter of transistor is heavily doped. This is also direct question. Why we are doping emitter? To supply maximum carriers. So to supply more carriers is the correct answer. So option B is the right one. Next, when VGS of a FET changes from minus 3.1 volt to plus 3.1 volt and drain current changes from 1 milliampere to 1.3 milliampere, okay, so what we have to do, the trans conductance will be, what is that? Trans conductance, we know GM is equal to del IB divided by del VGS. So IB changes from 1.1 to 1.3. So difference is 1.3 minus 1. VGS changes from minus 3.1 to plus 3. Minus 3 to plus 3.1 volt. Right. So minus 3. It is not minus 3.1. It is minus 3 volt to plus. Okay. This is what the question is. Minus 3. I change it. Fine. So it is minus 3 to plus 3.1. Okay. So
minus 3 to minus 3.1. Okay, so I change the question, it is minus 3.12, fine, minus 3 volt, minus 3 volt. So what happens here, it is changing from minus 3 to minus 3.1, fine. So what happens, it is 0.3 milliampere divided by 0.1 volt, fine. So okay, the change in current is very important. It is changing from minus 3.1 to minus 3, right? So which is higher value? This is higher value, this is lower value. So higher minus lower we should do. So if we simplify, 0.3 by 1 is nothing but 30 milliampere per volt, that is equal to 30 millisiemens, right? So conductivity, so transconductance, so 30 millisiemens is the right answer. Okay, next one is FET is better than BJT because it has high input impedance and low input current. So the answer is both A and B. Fine, right. So the next question is, thermal runaway is not possible in FET because as the temperature of the FET increases, what happens? Conductivity, transconductance increases. So hence thermal runaway is not possible. Direct question. FET is a desk device, it is a voltage control device, whereas BJT is current control device. Current control device. Okay. Direct question. Next one. If n-channel JFET has following characteristics, find ID. So what is drain current? We know drain current formula is ID is equal to IDSS minus 1 minus VGS by VP whole square. So IDSS 20 milliampere, 1 minus VGS minus 4 divided by minus 8. So it is 1 by 2, 0.5, 1 minus 0.5, 0.5. So it is square, right? So it is 5 milliampere. So fine. So drain current is what they asked, ID is 5 milliampere. Fine. Okay. So I think the answers options are given wrongly. So ID is equal to 5 milliampere. Please note down. Okay. Next one. Amplification factor in FET is given by, amplification factor is nothing but ratio of a drain to source voltage to the ratio of it is a ratio of drain to source voltage to the gate to source voltage. This is the answer. But we know VDS by VGS is given by VDS by del ID into del ID by VGS. VDS by del ID are okay. This is del. So del VDS by del ID is nothing but drain resistance RD. This del ID by del VGS is nothing but transconductance. So RD cross GM. So both B and sorry C. It is nothing but A and B, not C and D. So both A and B are correct. Okay. So the answer is VDS by VGS. Okay, so RD into GM. Both are representing amplification factor. Okay, if FET has VP is minus 8 volt, VGS minus 4 volt, GMO is 5000 microsiemens. What is transconductance? We know transconductance is given by GM is equal to GMO 1 minus VGS by VP. GMO is 5000, 1 minus VGS minus 4 divided by minus 8. If you simplify, it is 2500 microsiemens. So the answer is 2500 microsiemens. Siemens. Okay, done. The next question is the capacitance of reverse biased PN diode. What is that? What happens? It increases as reverse bias is decreased. So option A is the right answer. Direct question. In a PN diode, potential barrier is due to, it is due to, it is not due to minority carriers only, majority carriers only. It is due to fixed donor and acceptor ion. So option C is the right answer. Okay. The next question is they have given circuit. Determine the current through the circuit. Assume diode is real, right? So we have to find current through the circuit. Let us see how we are going to do the problem. Okay. So we apply KVL. What happens? So this is from here I start. So -5, right? So diode voltage drop, I assume it is 0.7. Here it is 0.7. Plus minus plus minus. So -5 volt plus 0.7. This is 1.5 ohm. So it is 1.5 into I. The current flowing through the circuit is I. Plus 0.7 is equal to 0. 1.5 kilo ohm. 1.5 kilo ohm. Please understand it is 1.5 k ohm. Okay, done. So what happens? This indicates I is equal to what you call 5 minus 0.7 divided by 1.5. Right, so it is 5 minus 1.4 is 3.6. This is 1.5 into kilo ohm. So 1.5 kilo ohm. Okay. So this will give, if I multiply by 0.3, it is 12 by 5 into 10 power minus 3. So it is 4 means 2.4. 2.4 into 10 power minus 3, 2.4 milliampere. So option, none of this. So the answer is 2.4 milliampere. Okay. Next one, when a reverse saturation current in a particular Zener diode increases from 20 milliampere to 30 milliampere, the voltage changes from 5.6 volt to 5.65 volt. What is the resistance of the device? So resistance of the Zener diode is given by change in voltage divided by change in current. Voltage changes from 5.6 to 5.65. So change is this one. Current changes from 20 milliampere to 30. So 30 minus 20 milliampere. So 10 power minus 3. This indicates it is 5 ohm. Okay. So the answer is 5 ohm. Okay, is there anything else? We have option C. Next one, 4.7 volt Zener diode has a resistance of 15 ohm, not watts, right? Please change it. It is 15 ohm. So when the terminal current is 20 milliampere, what is the terminal voltage? So what they have given? They have given 4.7 Zener diode. So VZ, Zener voltage is 4.7 volt. Right? Zener resistance is 15 ohm. And Zener current 20 milliampere. Right? Zener current is 20 milliampere. So what is the thing? Terminal voltage they are asking. Terminal voltage is given by VZ dash, that is equal to VZ plus IZ RZ. VZ is 4.7 volt plus IZ is 15. Sorry, RZ 15, IZ is 20. Okay, 20 milliampere, 20 into 10 power minus 3. If you simplify, what you get is 5 volt. So the answer is terminal voltage is 5 volt. Right, I hope you understand all the 25 questions. Right, so if you have any doubt, please ask me in comment section. I will clarify. Thank you.